Okay, picking up where we left off, we're going to jump into writing some hypotheses and then take this a little bit further and start interpreting the p-value and thinking about a conclusion. So in this check your understanding, you should be able to do number one, no problem. So why don't you pause the video and do number one based on what we just talked about on page 4. So as I read through this question, calcium intake, 1,300 milligrams, I see units. Okay, right there, that's all I need to know. This is going to be quantitative. It does not ask you to express the parameter. That's something that we're going to do 99% of the time. Here, I'm not going to. So the claim is that the average calcium intake should be 1,300 milligrams. They're concerned that teenagers are not getting enough calcium. Well, that would mean that they're getting less than 1,300 milligrams. So that's the null and alternative hypothesis. So they decide to do a test. They asked a random sample of 20 teens to record this stuff for a day. Data analysis reveals a sample mean of 1,198 milligrams and a sample standard deviation of 411. They performed a significance test and got a p-value of 14.04. So, in order for the null to be true in this setting, I'm just putting this into words. So that would mean the true mean daily calcium intake for all teens is 1,300 milligrams. That's what it would represent if the null hypothesis was true. So remember, when I get to this part, interpreting the p-value, it's if the null hypothesis is true, then what's the likelihood we got this sample result or something more extreme? So I'm going to start with the same idea, assuming, for the sake of time, I'm going to do this. Assuming the true mean daily calcium intake for all teens is 1,300 milligrams, comma, there is a 0.1404 probability that they told me that was the p-value of getting a sample result of 1198 milligrams. Or now, how do I decide if it's greater than, less than, just more extreme? I look at the alternative. It's less than. So this would be or less, purely by chance. So if indeed teens get 1,300 milligrams of calcium a day, the likelihood we get a random sample to have an average of 1198 or less happens about 14% of the time by chance. So are we shocked? No. 14%, that's not statistically significant. So the conclusion we're going to make, remember, this is what we call our significance level. Why are we using the word significant? Because if the p-value is less than this, we have statistically significant results. So here's the structure I'm going to follow. Because the p-value, I'm going to be very clear about what it is less than alpha equals 0.05. It's not less than, it's greater than. We do something called fail to reject. We fail to reject the null hypothesis. We fail to reject. Basically, we haven't found enough evidence to convict someone and say they're guilty. So there is not convincing evidence. So the idea, we don't have enough evidence that the true mean calcium intake is less than 1,300 milligrams. This evidence that I'm talking about is for the alternative hypothesis. Always. We don't have enough evidence to support that other claim. All right. Lots to take in here. Lots to take in. Okay, so just building off of this is going to be very similar. So what I'd like for you to do is, where are we at? 6. Yeah. Work through this whole page. There's nothing new here. It's just a good opportunity for you to practice these skills. By no means do I expect you to get all of this right. Don't worry about that. Just practice the skill. So pause the video, take 5-10 minutes, work through this page, use the rest of your lesson as a resource, then jump back when you're ready. All right. I've said all right in this video about 6,000 times. I'm going to try to stop saying that. Almost just said it. Here's what we know. This Bureau of Labor Stats estimates that 69.7% of graduates go to college or university. Bernard has great pride in the quality of his large high school. He thinks it's going to be actually higher. So here's what I know. People either are going to university or not. So this is categorical. I'm going to use a proportion. So the null hypothesis is going to be P is equal to this claim. The alternative would be P is greater than that claim. That's what he believes. Now it goes on to ask, or say, he asked a random sample of 40 of last year's graduates if they are enrolled. 34 say yes. All right. So what evidence do we have for the alternative? Well, we have our sample evidence, which is the 34 out of 40 is 85%. Notice I used the symbol P hat here. That's the alternative. What am I saying? That's the sample proportion. So we do have some evidence. Is it enough? We're about to find out. What are two explanations? So think back to the basketball question we started with. Either the real proportion is about this 70% and this just happened by chance. Maybe he just happened to ask a lot of people who did go to college. Or, in fact, he is right and the true proportion for his high school is bigger than this 70%. And that's what we're looking at there. So he does a significance test and he gets this p-value 0.018. So it asks you in part D to interpret that. Well, the interpretation is assuming the null is true. So putting some context behind that, assuming the proportion of grads enrolling in college or university is this 0.697, there is a 0.018 probability of getting a sample result of 0.85 or more. You'll notice now, why is it or more? Go back to the alternative hypothesis. It's greater than or more purely by chance. So now, if I think about this, this is not happening very often if 69.7 is the true percentage. So now I start to think, I don't believe that this is the true percentage. And that gets into part E. The conclusion we would make is because our p-value, oops, I don't like that I didn't write it. Our p-value equals 0.018. You want to write it as part of your communication every time, is less than alpha equals 0.05. We reject the null. So now we do have convincing evidence. So in a court of law, we do, as the jury, have convincing evidence this person is guilty. Otherwise, we say we don't have enough evidence, we don't have convincing evidence, and they're not guilty. So there is convincing evidence that the true proportion of grads enrolling in college or university is greater than 0.697. The evidence is always for the alternative hypothesis. So I'm always talking about evidence for this counterclaim. Hopefully you found that to be a little bit of a success, and we're going to have another opportunity to build on it here in a moment. Yes. Okay. So if I go on to page 7, this is just a summary of the conclusions. We've written a couple so far. You're going to compare your p-value to your significance level. If it's less than that, we're going to reject the null because it hardly ever happens by chance, that result. And we have convincing evidence for the alternative. If the p-value is greater than or equal to, guess I got to move my mouse every so often, then I'm going to fail to reject the null, and I have convincing evidence for the alternative. So in this question, same deal. Work through this question on your own. You have all the tools and resources you need. Pause the video now and do that. Come on back when you're done. We'll talk through it. Here we go. I'm going to go through this one a little bit quicker. They're either speeding or they're not. This is categorical. They're convinced more than 20% are speeding. the null P equals 0.2, the alternative P is greater than 0.2. So what evidence do we have for the alternative? In our sample, 28% of the cars were speeding. What are the explanations? Well, maybe 20% really speed, but we just happen to get a high percentage of speeders in our sample, happened by chance. Or more than 20% of the drivers are speeding in this area. Interpreting the p-value. Assuming the true proportion of cars speeding is 0.2. That's assuming the null hypothesis is true. There is a 0.023 probability of getting a sample result of 0.28 or more. That's the whole idea of this alternative hypothesis, by chance. So it does not happen very often by chance if the real percentage is 20. So we start to think it's not 20. Conclusion, because the p-value is less than the significance level, we reject the null. There is convincing evidence that the true proportion of cars speeding is greater than 20%. So that goes along with what we did on the previous page, just kind of building that structure. And that structure is going to be really important as we continue to move forward in this unit and on to the next units. All right, this next page is just kind of talking about conclusions a little bit more. So they give you some hypotheses about batteries, and they give you a p-value. So what you want to do here is just write the conclusion. So on the previous page, let me see where I put it. The last step that we did where we're doing this process, this is what it's asking you to do for part A and part B. So take a minute, pause the video, work through part A and part B, trying the conclusion. Hopefully you're getting a little bit better. I don't expect perfection, nor should you. So let's go through these two. In part A, the significance level is 10%. And we have, let's see, a p-value of about 8%. So because the p-value is less than the significance level, we reject the null. As long as it's low, we reject H sub O. There's convincing evidence that the true mean battery lifetime is greater than 30 hours. The evidence is always for the alternative hypothesis. Part B, now that p-value is greater than 5%, so we fail to reject the null. So now we do not have convincing evidence that the true mean battery life is more than 30 hours. So we'll start talking more about like, why do we choose different significance levels? What's the benefit? What's the drawback? It just depends on the scenario. All right, little summary here on the bottom. Significance test, basics. We've talked about the idea of hypotheses. You're always using parameters, and the null is going to be equal to that value, and the alternative is going to be greater than, less than, or not equal to that value. Interpreting the p-value in context, we've talked about that. You can use this generic language or more extreme. That will take care of, is it more than, is it less than? If it's two-tailed, that we're going to be talking about less than and greater than. So, and then conclusion is just what we practiced that we've done a couple of times here. All right, so let's move on to page 9. What I put this in here specifically for something that you could do and get a little feedback on. We've had quite a bit of practice already, so kind of assess where you're at. Do you feel like this would be a quiz so far? Like, hey, how have I done? Do I understand what the heck is going on or not? So I would encourage you, pause the video, work through this exit ticket. I'm obviously not there to collect it and give you some specific feedback, but I will go over it here in just a minute. So pause the video, work through this, and we'll chat. So in the first question, we're talking about these boards cracking. So they either crack or they don't. So it's a categorical variable. The claim is the drying process creates cracks 16% of the boards. That's the null hypothesis. The drying supervisor wants to test a method to see if fewer boards will crack. So the alternative is P is less than 16%. So he does a simple random sample, dries them with the new method, and finds that 5 out of 50 or 10% have cracked. Now, you're going to have to kind of come up with a p-value here. They did a simulated sampling distribution. So they simulated 100 random samples, 50 trials. This is all based on the fact we are assuming p equals 0.16 is true. So this is centered at pretty much 0.16. So we want to know by chance how likely it is that we get 10% or fewer. So if I start counting up these dots, 1, 2, 3, 4, 5, 6, 7, 7 out of the 100. I guess I can't count. I'm not sure where that came from. 2, 4, 6, 7. Yeah. So I disagree with what I have written here. I would say that this is 0.07, not 0.1. So what are two possible explanations? That the true proportion is 16% and this p equals 0.07 just happened by chance. Or the real proportion is less than 16% and this method did work. So use the results of the simulation to estimate the p-value. We've already done that. That is the... Oh. Timeout. I understand what was going on here. I wasn't wrong. What evidence do we have for the alternative? Our sample proportion was 10%. That's what happened in the sample. So we're saying that the real percentage is 16% and the 10% did just happen due to chance. I got ahead of myself. So I guess I should be able to count to 7, I would like to think. The simulation results, that p-value is the 7 out of 100. We've already talked about that. Interpreting the p-value, assuming the null is true, assuming the true proportion of cracked boards is 16%, there's a 0.07 probability of getting a sample result of 0.1 or less purely by chance. Okay, using our default significance level, because the p-value is greater than that, we fail to reject the null. There's not convincing evidence that the true proportion of cracked boards is less than 16%. So one thing I did to cut corners here, I didn't write this out in context. You need to do that. So be mindful of that. So that's really the big first chunk of section 9.1. There is a lot here. In the next video, I'm going to talk about errors type 1 and type 2.